Welcome to EPG Pathshala. This module deals with a very well-known phenomenon of greenhouse effect and global climate change. Everybody knows that the temperature of Earth's atmosphere is increasing, and all human beings and countries are concerned with this, and efforts are being made to control this temperature increase. Here in this module, we will learn what is greenhouse effect, what are the causes of the greenhouse effect, what are the damaging effects of greenhouse effect, and how we can control it, and what the governments are doing about it. The first important question is, what is climate? National Aeronautics and Space Administration, well known as NASA, defines weather as follows. It considers the short-term, minute-to-month change in the atmosphere. So, weather is a day-to-day phenomenon. Most people think of weather in terms of temperature, humidity, precipitation, that is rainfall, cloudiness, brightness, visibility, wind and atmospheric pressure, as in high and low pressure. Climate is the long-term behavior of the weather in a particular area. Its description includes the following parameters. Yes, if we want to define climate, we will look for the following parameters. Number one, averages of the temperature and rainfall. How many rainfall? Average rainfall is every year. What is the average temperature in different regions, seasons? The extremes of temperature and rainfall and frequency of their occurrence. That is, how many times the temperature, for example, here goes to 48 degree or 42 degree, goes to 5 degree, or rainfall is how many times 20 centimeter or 100 centimeters. So these are the extreme. They are necessary to understand the climate behavior. Meteorological measurements such as wind velocity, air pressure, solar radiation, humidity, precipitation, atmospheric particle count, and cloud cover, etc., over a long period of time in a region, they are also necessary. So these are 3 points are basic necessary for defining the climate. Now, what are the factors which determine the climate? Remember, the most important factor is this. What is at what angle the sun radiations strike the Earth's surface. If it strikes directly, for example, at equator, it will be very hot. The number of photons reaching Earth's surface per unit area per second would be very high. At poles, the angle is slanting. The sun ray strikes Earth's surface at a slanting angle. The number of photons per unit area per second is small. So, equator is very hot and the poles are cool. Another point is general circulation, which is determined by the ocean currents and global wind system, is responsive for rich distribution of heat. Wind system is broken into different cells by Earth's topography and rotation to produce characteristic patterns of prevailing winds. The drastic changes in the climate are driven by the following natural and anthropogenic factors. The important point. Natural factors. What natural factors bring a drastic change in the climate? A small natural change in Earth's orbit around the sun. The Earth rotates around the sun, and at an angle, this angle may change. And when it happens, the seasonal distribution of solar energy which the Earth receives will also change. The sun does not emit radiation at a constant flux. Sometimes hot sun, very strong radiation, high photon density, and sometimes cool sun, low photon density. Volcanic eruptions send dust clouds high in the atmosphere, and these scatter the solar radiation back in space. They increase albedo and lowers the temperature. And the last one is atmosphere-ocean interaction. What are the anthropogenic? These are natural factors. The man-made factors, there is a new dimension which was not present about 150 years ago. This is the increase in the concentration of greenhouse gases such as CO2, CH4, N2O, CFCs, ozone, etc. We will discuss the effect of these gases later on. Climate change in the past. The Earth has been for billions of years in existence. How the climate has changed during these billion years? Remember, there is no temperature record of the previous years, but measuring this ratio O18 by O16, it is possible to know the temperature of that particular time, okay, from this ratio. So what is done? The samples are drawn from ice cores, ice deep inside the earth, and ocean sediments. The temperature record of the past million years can be made, and it has been made by measuring this ratio. Because this ratio takes a particular time for ratio to change, for a particular amount, to ratio change by particular amount, particular number of years are required. So by this ratio you can do it. Warming and cooling cycles have been found in past too. Previously also, say for example in 1900, England was very cool. The Thames river was almost frozen. So not necessary that only warming is today, the warming has been in past also. For example, in this 1500 AD, there was warming, and between 1400 to 90 there was global cooling, called littleness. The example of I gave the Thames river you right just now. So the theory says the next ice age will be about 5,000 years hence. Then there will be low temperature. What is greenhouse? The greenhouse is used in plant science. It is made up of glass walls and ceiling. Everything is of glass, ceiling and walls. It is used for growing trees and plants under controlled climatic conditions. What is the purpose of greenhouse? In the greenhouse, within greenhouse, you can control how much temperature you want to maintain, what humidity you want to maintain, what solar radiation you want to maintain. So this is possible under selected conditions. You can grow selected species. The glass walls and ceiling are transparent to solar radiation because they allow, if there is a greenhouse made up of glass and ceilings made up of glass, so the solar radiations are allowed to enter in the greenhouse. These glass walls, they don't absorb them. These radiations enter the greenhouse, but glass does not. But what happens? Remember, I repeat it. The glass has a peculiar property. If I have a glass here and I shine the solar light, the light will pass through it. But if I shine infrared radiation, the infrared radiation cannot pass through the glass. So glass does not allow infrared radiations to pass through it. So what happens? When in the greenhouse, the solar radiation come, they are allowed to go inside. When they go inside, they heat it, and when they heat it, the hot body releases radiation, and these radiations are of infrared type. I will explain later on why it gives infrared radiation only. So then what will happen? These radiations, infrared radiations, are not allowed to go out of the greenhouse. Therefore, the temperature in the greenhouse rises. So this is known as greenhouse effect. Now, come to the real situation. Our Earth is surrounded by atmosphere. There is no glass walls. There is no glass ceiling. But atmospheric gases itself, they behave like glass walls and do not allow the infrared radiation released by Earth to go out to space. And these gases are called greenhouse gases. Atmosphere is transparent to solar radiation. It will allow the solar radiation to come in, but this will not allow to infrared radiations to go out. So we can define it. The infrared radiations emitted by the Earth are not allowed by greenhouse gases. For example, this resulting in the warming of the atmosphere, this is called greenhouse effect. It must be pointed out why the Earth releases only infrared radiation. According to the black body, a body releases radiation of a particular wavelength depending upon its temperature. That is known as sigma T to the power, energy E equal to sigma T to the power 4, where sigma is a constant. T is the temperature. Higher the temperature, higher will be the energy, lower will be the wavelength. The Earth has a low temperature. Therefore, it releases low energy, and therefore radiations of low energy, high wavelength, that is infrared radiation. Now, to understand about greenhouse effect better, we understood the solar and terrestrial spectra. What is solar radiation? the spectrum of solar radiation, the radiations received from sun on Earth's surface, this is the spectrum of that. And this is the spectrum of the radiations emitted by the Earth's surface. Okay, they are largely infrared, and the radiations reaching Earth's surface are mostly visible radiation. Other radiations are there, but their fraction is small there. And the maximum is radiation of this green light, about 500 nanometer. They are all, this Earth has a temperature, this temperature. So at this temperature, as I explained you, low temperature. Therefore, the radiation that will be given out by Earth, infrared. Here the sun temperature is very high. So the radiation that will be given out will be of high energy and low wavelength. Now the solar radiation spectrum, what are the properties? Sun acts a good black body with a surface temperature of about 5800 Kelvin. Important characteristic of solar spectrum are as follows. Solar radiation peaks in the wavelength of 400-700. This maximum wavelength that we receive on the Earth's surface are in this range. Maximum radiations are of this 500 nanometer. Nearly half the radiations are of less than 700, greater than 700 nanometer. Only a small fraction is the UV range, less than 400 nanometer. The radiation flux at sea level is lower than at the top of the atmosphere due to the reflection by clouds, etc. Major absorbers of UV radiations are O2 and O3 in upper atmosphere. In stratosphere, the water vapors along with other greenhouse gases are major absorber of infrared radiations. The absorption is 100% efficient in OV region in electronic transitions of O2 and O3 in upper atmosphere. Atmosphere is largely transferred to visible radiation because energy is too low for electronic transition and too high for vibration transitions. It means to say that the solar radiation which are mostly visible, they are not absorbed in the atmosphere by O2, N2, CO2, water, etc. other gases. Why it is not absorbed? Because in these molecules, either there will be electronic transitions or vibration transitions. For electronic transitions, you need high energy, UV energy. And for low transitions, you need infrared energy. Since both of them are virtually absent, so these are not absorbed here. The terrestrial radiation is the radiation emitted by the Earth's surface. And these are infrared radiation. You can call them infrared radiation, you can call them terrestrial radiation. Look here, this is the terrestrial radiation, this one. This is the terrestrial radiation, and this terrestrial radiation, what are its properties? Earth also behaves as a black body, and important characteristics are the radiation spectrum is a combination of black body spectrum of different temperature ranges from T20 to 320, depending upon the temperature, what is the highest temperature or lowest temperature. The wavelength of the maximum emission is this. Maximum radiations are of this wavelength, infrared. The absorption of terrestrial spectrum is almost 100% efficient due to greenhouse gases, except in this 8,000 to 1300 nm. Look here, this 1300 to 8,000 to 8,000 to 13,000 nanometer. These wave radiations, they directly go to space because in atmosphere there is nothing to absorb them. This is known as atmospheric window. Radiation balance of Earth and atmosphere, what happens? When the solar radiation come to it, what happens to them? Remember, the solar radiation received at the top of the atmosphere is how much? Maybe 2,000 kilometer or 5,000 kilometer, whatever it is maximum height at which this is 342 watt per meter square. Watt is equal to joule per second. That is unit watt equal to this. For the sake of simplicity, assuming this is 342 comes, we can make the calculations with this also, but it becomes much easier if we assume it to be 100. 100 units is received, remembering that 100 units is equal to 342 watt per meter square. In percentage terms, now things can be explained easily. The total energy, remember this is the top of the atmosphere, here 342 comes. The total or 100, the total 100 units energy received at the top of the atmosphere is appropriated as follows. About 9 units are reflected back by reflected back by Earth's atmosphere. The atmosphere itself reflects back. They don't come to Earth's surface. About 49 units are absorbed by Earth's surface. This Earth's surface, it absorbs 49. 22 units are reflected back into space by clouds, aerosols and gases. There are the clouds. When the solar radiation strikes the clouds reflect back to the space. Aerosols, they reflect back. Actually, they have a cooling effect because they do not allow the solar radiation come to Earth, heat up the Earth. Therefore, important point, we will discuss it later on. About 20 units are absorbed by the atmosphere itself, absorbs 20 units. So, this total, you can count it. This is 100, 9 plus 49 plus 22 plus 20, it is 100 units. So, this is the account of 100 units. What happens to 100 units? That solar radiation come to our atmosphere. Energy balance of the Earth. How the energy balance, Earth is balanced? Remember, 49 units are absorbed by the Earth's surface. So, this is here. About 49 units are received from the solar radiation, which is absorbed by the Earth. About 95 units are received in the form of long-wave radiation from the atmosphere. In addition, they come for solar radiation and 95 units are reflected back to Earth's surface by greenhouse gases. So, total energy reaching Earth's surface is 144 units. You can add them. This energy, now what happens to this energy? Earth's surface comes, about 114 units are radiated back to the atmosphere as a long wave radiation. Okay? The Earth reflects back 114 units back to the atmosphere as long wave radiation. About 23 units are used evapotranspiration, the evaporation of the water, which are ultimately released as latent heat in the atmosphere. About 7 units are transferred to the atmosphere by heat fluxes associated with turbulence, convection, etc. When the air strikes the Earth's surface, it gets heat up and they takes the energy and goes up. So, that is about 7 units. Now, energy balance of the atmosphere. How energy is balanced? What is the account of energy? Atmosphere absorbs 20 units from the solar radiation, absorbs 102 units from the long wave radiation released by Earth's surface. Atmosphere receives 30 units from the latent heat and thermals. Thus, energy received by atmosphere is 150 units. The gases, clouds, aerosols present in the atmosphere re-radiate 95 units back to the Earth in the form of IR radiation, about 57 units to the outer space. So, this 95 units which are sent back to the Earth, not allowed to go, this is responsible for global warming, increase in temperature. Thermal equilibrium of the Earth. At top of the atmosphere, 100 units of energy are coming and 100 units, 69 from outgoing IR radiation and 31 from reflected radiation are outgoing. So, total is 100 this. The global mean average Earth temperature is 288 K or 15 degrees Celsius. 15 degrees Celsius doesn't mean that everywhere it is 15 degrees. See, for example, in Jaipur, it can be at this point of time 33, but at some other place it can be minus 10. That is the average. How do we calculate the mean temperature of the Earth? The total solar radiation ES emitted by the sun. Remember the sun, the temperature of the sun is this, per unit time is equal to the product of the radiation flux. This is Stephen constant. And Ts to the power, the temperature of the sun, this is in Kelvin, and this is area of the sun's surface, 4 pi rs square, the rs is the radius of the sun. If we work out it, we can substitute these values and we will come later on what happens. The distance of the Earth from sun is 1.5 into 10 to the power 8 kilometer. You can remember this, how big. The solar radiation flux Fs is distributed uniformly over the sphere, centered at the sun, having the radius of d between sun and Earth. Here is the sun, here is the Earth. This is the distance d between Earth and sun. Now draw a sphere of this radius. So, the solar radiation flux Fs is distributed uniformly over the sphere, centered at the sun, having the radius of d between sun and Earth, and it is given by the following equation. This flux is equal to total energy divided by the area. On substituting the value of Es into this, we get this equation. Fs is intercepted by the Earth over a disk of cross-sectional area pi r square, where r is the radius of the earth. Remember, whole of the earth is not exposed to sun. Only part of it is exposed. It has been showed by physics derivations that this is the area which represents the shadow area of the earth and which intercepts the solar flux. A fraction A of the intercepted is reflected radiation, this must be radiation. A fraction A of the intercepted radiation is reflected to space by clouds, ice and others, and this is value is 0.28 to 0.3. It could be 0.27 to 0.31, differ from books to books, from scientist to scientist, and this is known as planetary albedo or albedo. This term, important term, that is this much amount of radiations are reflected back to space, they are not allowed to come out. The radiation absorbed by the earth per unit time. This is the mean solar radiation flux absorbed per unit area of the earth per unit time is this. You can solve it. To cut the long story short, if we make all these derivations, but one point I want to emphasize is this, how the atmosphere acts to the radiation. If this is the atmosphere, the radiations are coming from the earth. It absorbs, the gases present here, CO2, H2O, they absorb this radiation. They go to excited state. Remember, excited state is short-lived. It is a lifetime of 10 to the power minus 13 to 10 to the power minus 14 seconds. It means that once it has gone to excited state, it will release the radiation. What it does, when it releases the radiation, half go up and half come down. So this half come down, they are confined to the Earth's atmosphere and they are responsible for increase in temperature. This involved calculation in this equation by substituting the values of A, F, etc. The global mean temperature is found to be 288 Kelvin, as is found experimentally by calculations. Now, there are different kinds of greenhouse gases. Do the all greenhouse gases behave similarly, or they have different characteristics? They have different characteristics. Some gases absorb more radiation than the others. The term is global warming potential. Definition is the total global warming expected from 1 kilogram of a gas over a 100-year period is called global warming. A gas which has high global warming potential will be more responsible for increase in temperature. If relative global warming potential CO2 is assumed to be 1, then CH4 is 21 times more potent in increasing temperature than CO2. N2 is 290 times. And the CFCs, they are 1,000 times more active in absorbing the radiation. So, remember, so they are strong substances, but what happens? Their concentrations are small, and its concentration is very high. So, despite its small, lower global warming potential, it is the main culprit for increase in temperature rather than these, because their concentration is relatively much small as compared to this. Now, how the global temperature is actually varying? Look here, see. NASA's Goddard Institute of Space Studies is carrying out the temperature measurement continuously. And over the year, this has happened. Look here. So, this is how the temperature is changing. So, now there is a continuous record. You can go to internet, just temperature of the globe, you will find. Or NASA's Goddard Institute of Space Studies, you type it, you will get the whole data available. Now, this is the estimate. According to IPCC, International Panel for Climate Change, according to it, the temperature is likely to increase by 0.6 to 4.0 with attached uncertainty since 2000 to 2100, depending on the change CO2 concentration and other factors. Remember, there are estimates, and if you think that increase 0.6 is nothing, you are quite wrong. 0.6 is the average. It could mean 10 degree at some place, or can mean 5 degree or 1 degree at one place. So its meaning at different places will be different. Actually, the averages are always risky. the relative contribution of different greenhouse gases, the calculations have been made based on their global warming potentials and their concentrations. CO2 contributes 66% to global warming, methane contributes 17% to global warming, CFCs contain 12% to global warming, and remaining gases contribute 5%. A very useful and popular term is radiative forcing. What is radiative forcing? The radiation balance of the Earth atmosphere system is perturbed or rather disturbed by the change in the concentration of greenhouse gases and aerosols. This perturbation in radiation balance is called radiative forcing. Perturbation radiative forcing is defined as the perturbation to the net irradiance, this is the unit, at the top of the atmosphere. An increase in the concentration of gases makes the perturbation positive, that's increase in temperature. A decrease in the concentration will lead to a negative perturbation and decrease in temperature. Greenhouse gases, these are the gases, these are gases. What are their sources? Largest sources of CO2 is the combustion of fossil fuels. Deforestation is another. Because if there is no forest, there is no tree, then what will happen? The trees act as a CO2 carbon bank. They do photosynthesis, they make food, and the CO2 is stored in a plant. If there is no plant, it will make no food. So you can understand how important deforestation is to climate change. The trees and plants work as a carbon bank. Human activities have led to net increase in CO2 level. Beginning with Industrial Revolution, there is a rising trend in the concentration since 19th century. Since 1957, it is continuously measured at this place, Mauna Loa, Hawaii. The estimated CO2 concentration was 280 ppm before the Industrial Revolution, that is around something 1857, when the steam engine was invented. On May 10, 213, NOAA reported daily average which temperature around 400. I just checked a month ago, the CO2 concentration is around 400 parts per million. Methane is another gas, which is a greenhouse gas, and it is released by ruminants, the elements, as a stomach gas. Cow, buffalo, goat, and also in paddy fields, anaerobic biodegradation, in marshy lands, in landfills, and coal mines. There are other sources. And one of the important sources is ruminants, stomach gas. Nitrous oxide, there is no biological processes in soil and ocean are the main source. That is degradation, biodegradation of nitrogen compounds produces N2O. Increased use of nitrogen-based fertilizers is believed to be another cause. Other sources are change in agricultural practices, industrial manufacture of nylon. Chlorofluorocarbons, deadly for increase in CFCs, and also because it has a very high value of global warming potential. These are man-made compounds. There is no known natural source. These are inert and non-toxic and have a long lifetime of about 100 years. Tropospheric ozone is again a greenhouse effect. Tropospheric ozone contributes to the groundhouse effect. According to the 4th IPCC assessment report, it is the third main greenhouse gas after CO2 and CH4 because of its radiative forcing of this 0.35 watt per meter square. The global warming due to climate changes are helpful in tropospheric ozone formation. And if ozone is formed, it is harmful if it is present in troposphere. What are the consequences of global warming? The vegetation will be affected. The yield from some plant species may increase due to increase in CO2. If there is more CO2, the plants need CO2 for their food production, for fruit. And some species, due to increase in CO2, may give better yield. There is strong likelihood of alteration in the distribution. Yes, this is important point. Species. Some species may be able to adapt to the changed climate. For example, wheat. Wheat grows here. Can we grow wheat in very cold region? Can we grow paddy in very cold region? So, can we grow apple in Rajasthan? If suppose the temperature of Kashmir becomes that of Rajasthan, what will happen to apple? Apple will not grow. And apple cannot change itself with change in climate rapidly. So some species will be lost. They will not be able to grow there, just vanish. Now, some new species, including weeds and pests, may be introduced with the change in climate temperature. In colder areas, the growing season for grasses and trees could increase. This could help increase the viability of the grassland, animal farming and forestry. This is true for cold regions. With increase in temperature, it will be easier for the plants to grow. It is positive for them. Change in rainfall pattern, increase in frequency of droughts might seriously affect the agriculture production. But most difficult thing is, there will be change in rainfall pattern, there will be change in the frequency of drought, but where and how? One cannot predict whether the rainfall will be more in Rajasthan or in Kashmir or in some other place. That is the pitfall of all environmental science, meteorological science. Another thing, sea level rise. Sea level rise will result in the following two important processes. Remember, what happens? Sea is full of water, and with increase in temperature, all liquids expand, the water will also expand, it will occupy more volume, so it will rise. Glaciers and land ice sheet will melt, and when glaciers and land ice sheets will melt, there will be more water in the rivers and there will be flood. The obvious consequences of our two factors is the rise in sea level. According to IPCC, modeling indicates a likely range of global mean sea level rise in this range, 0.26, 0.82 meter. But remember, they are all estimates. They are not, you cannot say that they are correct, they are absolute values, they are just estimates. Sea level rise has several implications. Number one, increased frequency of storm surges, consequent flooding, for example, tsunami type, reduction in quality of groundwater due to salination, loss or disruption of coastal ecosystems. In this module on greenhouse effect, you had an opportunity to learn what is greenhouse effect, what is a greenhouse, what is climate change, what are the factors which determine the climate change, what are the greenhouse gases, what are their sources, how infrared radiations are released by the earth, how they are absorbed by gases and they lead to the global warming, what are the consequences of greenhouse effect. Thank you.